rational inequalities. So we'll have at least one rational expression and an inequality when we're working on our inequalities. We're going to solve these similar to our quadratic inequalities. One topic that we talked about in the quadratic inequality videos is that we were getting a 0 on one side so that we could determine 0 values. One extra part that we're going to have to worry about with a rational is that we also don't want a denominator to equal 0. So that's also a very important value to have on our number line. So let me go ahead and start with example 10. We have 6 over x minus 3 greater than or equal to 4. And I'm going to move the 4 over, so 6 over x minus 3 minus 4 is greater than or equal to 0. And I need to get common denominators to make this into one fraction. So 6 over x minus 3 minus, I'm going to make that plus a negative 4, and then I'm going to multiply by x minus 3 to both numerator and denominator to get that common denominator. So we got 0 on one side by itself, and now we're working to get the two fractions into 1. So we have 6 plus, I'm going to distribute here, negative 4x plus 12. And in the denominator, we just have the denominator x minus 3. Simplifying, we get negative 4x, the 6 and 12 together make 18 over x minus 3. So now what we want to look at is we could have a negative in the numerator and a negative in the denominator, and that would be a positive. Or we could have a positive in the numerator and a positive in the denominator, and that could also be a positive. So again, we want to test the regions. How we're going to get our regions is we're going to use the numerator to find the 0 value. So negative 4x plus 18 equals 0. And then I'm going to simplify this, dividing both by 2, actually negative 2, so I get 9 halves. We also want to find out anywhere that would be restricted from our domain that would make that fraction undefined. So x minus 3 cannot equal 0 because that wouldn't be in our domain. So on our number line, because we're restricting the 3, keep in mind 9 halves is 4 1/2, so 3 is on the left, and our 9 halves is on the right. I like to right away put a big open circle around my 3 so that I don't forget that that is restricted. So this is not in our domain. And I am big on notes, so I kind of leave that note to myself that 3 is not in my domain. And now let's test regions on the left, in the middle, and on the right. So on the left, I could try 0. In the middle, something between 3 and 4 1/2 would be a 4. And something on the right is I could try 5 or 10. I'm going to go ahead and try a 5. So let me put 0 back into our original inequality. So I would have 6 over 0 minus 3. And is that bigger than or equal to 4? So 6 over negative 3, that's a negative 2, and that is not going to work. In the middle, trying a 4, we have 6 over 4 minus 3. Is that bigger than or equal to 4? So 6 over 1, and yes, 6 is bigger than or equal to 4, so we can use that one. Okay, just kind of to go ahead here at the 9 halves, because of the equal sign, we are going to include the 9 halves with the solid circle. Now let's go ahead and check 5, because again, we don't always have the pattern no, yes, no. We could end up with a double yes or a double no. So let me go ahead, and 6 over 5 minus 3 is greater than or equal to 4. So 6 over 2, 3 is greater than or equal to 4. That one's a no. So our final answer is going to be parenthesis on the 3 because it's not in our domain, and then all the way to 9 halves, but we're going to include the 9 halves because we were allowed the equal sign. And I'm going to go ahead and work on one more example, example 11. So notice that we have our rational term, and then we also are going to try to get it with a 0 on the other side. So 6x plus 1 over 2x minus 3 minus 6 is less than 0. And then I'm going to go ahead and get common denominators. And again, you know that I changed that to plus negative 6 to make it easier to remember. And I'm going to multiply by 2x minus 3, both to numerator and denominator, to get that common denominator. And now I'm going to write it as one fraction, 6x plus 1. And then I'm going to distribute to get negative 12x plus 18. And then over the common denominator, 2x minus 3. Simplifying the numerator, I have a negative 6x plus 19. And denominator 2x minus 3. And we're going to find those important values. So where the numerator is equal to 0, so that we can find out the 0 value. And we get x equals 19/6. So that one is going to be 3 1/6. And then we also want to look at where the denominator is equal to 0 because that's restricted from our domain. So x cannot equal 3/2. So on our number line, we're going to put those important values. 3/2 is 1 1/2, and 19/6 is 3 1/6. So I know 3/2 will be on the left, and 19/6 will be on the right. So here I can check 0. Something between 1 1/2 and 3 1/6 would be a 2 or a 3. And then on the right, I can test something like 4, 5, 10. I'm going to go ahead and go with a 4. So let's first check with our original inequality, and we have 6 times 0 plus 1 over 2 times 0 minus 3. Is that less than 6? So 0 plus 1 is 1, 0 minus 3 is negative 3. Is that less than negative 6? I can stop right there and know the negative is smaller than a positive. So yes, I want to shade in there. Okay. Oh, you know what I did last time that I didn't do this time? I'm going to do this now. We knew that that x could not equal 3/2, so I'm going to leave a big open circle there to say I can get close to it but never equal it because that's out of our domain. Let me check with the 2. 6 times 2 plus 1 and 2 times 2 minus 3, is that less than 6? So 12 plus 1 is 13, and 4 minus 3 is a 1, and 13 less than 6, that tells me no. Checking with a 4, 6 times 4 plus 1 over 2 times 4 minus 3, is that less than 6? So 24 plus 1 is 25, and then 2 times 4 is 8, and 8 minus 3 is a 5. That came out pretty nice. So 25 divided by 5 is a 5, and 5 is less than 6. We'll shade in that region. Okay. So now I'm going to go back and know that because it was only a less than, I'm going to use open circles or parentheses on both of those important numbers. So our answer in interval notation would be negative infinity to 3/2 with a parenthesis, and then also the section from 19/6 to infinity. And that ends example 11.